Hello, my name is Armantan Gupta, and today, over the course of the next couple of minutes, I'll be taking you through the process of manufacturing and designing a T-slot cleaner. I'll start by creating a drawing that has all the critical dimensions so that each geometry is fully constrained. From there, I'll create a 3D model from that drawing. Then, I will cover the layout tools and manufacturing tools you require to make it, and also list alternatives for all of them, so that regardless of the tools you have available, you should be able to complete this project. Once you know all the tools, I'll move on to the step-by-step instructions that you can use to complete the project. I'll also be showing some of these steps with computer-aided design and simulation software. Let's begin with the digital sketch and 3D model. As you can see here, I have created a sketch on Autodesk Fusion 360, which is a powerful, collaborative, cloud-based CAD software. You can see the dimensions for every line and arc listed as depicted in the orthographic drawing provided. Certain dimensions are driven dimensions, which means that they're not critical to determining the geometry and are only there for your understanding. These dimensions have been marked with brackets. Here's a bit more of a simplified representation with several orthographic and isometric views. It largely conveys the same information, however, machinists usually prefer this format since it's easier to see certain dimensions. Also, certain dimensions are unique to this format, such as the thickness of the T-slot, which is not possible to show in a single 2D orthographic view. Finally, with the details of that 2D sketch, we can extrude, chamfer, emboss, and countersink some holes to get our final 3D model. We can see that there's a 6mm through hole on it with an 8mm countersunk hole on both sides. Additionally, we can see that my name, which was embossed onto the piece of metal. Finally, we can note the sharp edges were chamfered as requested by the provided drawing. Now that we have a solid understanding of what we want to build, let's get into some tools that we're going to be required to mark our virtual design onto some physical stock material. The first thing you're going to want is some engineer's glue. Engineer's glue is great because it allows you to more clearly see any marks you make on the metal while covering up pre-existing scratches and scuffs. If you do not have engineer's glue, you can instead just use a Sharpie. However, do be noted is that the Sharpie markers are likely to fade away upon being exerted to heat, which almost all machining tasks produce. Next, you'll want a scriber. A scriber is used to etch marks onto a metal surface, preferably one that has had engineer's glue applied to it. These markings are much easier to see and will not get faded away due to heat, like pen marks would. If you do not have a scriber, you can use an X-Acto knife instead to make these incisions. However, it'll likely not be as accurate and comfortable with an actual scriber. Next, you'll want a letter stamp so you can emboss your name into the T-slot cleaner. The letter stamp works by simply placing it over where you want the letter to be engraved into the metal, and then hitting the top of the stamp with a hammer to make a dent with the shape of your desired letter into the metal. Unfortunately, there's not really a good alternative for this one. You could use a marker if you really want to be able to identify your T-slot cleaner, but this does not look nearly as good and it'll be easily washed away. As I mentioned, you'll need a hammer. Any kind of hammer with a flat side will work to hit the head of the stamp. The next thing you'll want is an engineer's square. The engineer's square makes it very easy to draw perpendicular lines to any given surface or edge. If you do not have an engineer's square, you can use a protractor and line it up to an edge to draw your perpendicular lines. I'm sure you know how to use a ruler. You'll be using it to draw straight lines and measuring distances those lines should be. If you want more precise measurements, you could opt to use a caliper. The next thing you'll want is a surface gauge, which is an extremely flat surface where the flatness is only off by around 1 thou at any given point. This makes it an ideal candidate to do any type of marking on. However, if you do not have this, a normal workbench, which is only kind of flat, will honestly be good enough. The next thing you'll need is a spring divider. A spring divider is used to scribe circles. Think of it as a scriber meets a compass. It works like a scriber, but instead of straight lines, makes arcs, just like a compass. If you don't have a spring divider, you can use a compass instead. One thing you'll want is a center punch. This is used to make a small indent in the center of wherever you want to drill. This is done so that the drill can more easily find its way and not slip and drill slightly off. This is especially prevalent if you're using a handheld drill. However, it does still help when using a drill press. Use a center punch similarly to the letter stamps. Simply place it in the center of a hole you want to drill and hit it on the head with the flat side of a hammer. If you don't have a center punch, feel free to use a thick nail in the same process, but make sure not to hit it too hard, otherwise you might damage your metal. Okay, now that we've covered what tools we need to mark out our machine cuts, let's talk about what machines we'll need to implement all that. The first thing you'll want is a benchtop vise that'll be used to hold any part that you want to work on, or that your machine is going to work on. If you don't have a vise, you might be able to use a C-clamp. The next thing you'll want is the bandsaw. A bandsaw consists of a continuously rotating blade that, when a material comes in contact with it, makes a thin cut into the metal. If you do not have a bandsaw, you can use a hacksaw, which is just operated by you moving the blade back and forth. The next thing you'll want is a file. Since the bandsaw will make a really rough cut, you'll want to use a file to shave off any excess material left behind. If you are very experienced, you might also be able to use a pedestal grinder to accomplish the same task. The next thing you'll want is what I talked about a little bit earlier, is a drill press. A drill press typically has a 3-jaw chuck where you're able to put drill bits into, and then when that chuck spins and the head is lowered onto your material, a hole will be drilled into the material. The advantage of a drill press is that it's very stable and always makes perpendicular cuts. However, if you do not have a drill press, you can use a simple handheld drill. The small indent you made with your center punch will help to guide the handheld drill. Additionally, you will also need 2 drill bits, one 6mm drill bit and one 8mm drill bit. The next thing you'll want is emery cloth. Emery cloth works by polishing the metal you rub it against. If you don't have emery cloth, you can use sandpaper, though it might be a bit weaker and not give you exactly the result you're looking for. But at least your part will be smooth and not have any jagged edges. The next thing you'll want is some cutting fluid, or coolant, or oil, whatever you want to call it. The purpose of the cutting fluid is to ensure that your parts or tooling of your machines do not heat up to the point of where it can damage either one. Using this will definitely increase the lifespan of your machine. Okay, now that we've covered all the different tools and their purposes and alternatives, let's get to the fun part, the actual manufacturing process. The first and most important thing we must do in the manufacturing process is safety. Our 3 A's come into play here. The first thing we want to do is be aware of our surroundings, so inspect the machine shop for any unsafe machines or people. Some hazards to look out for are materials blocking exits, spilled water, frayed electrical cables, machines without machine guards, lots of dust, and so much more. The next A we need to consider is attitude. If you don't have the attitude to be safe, no matter how much you know about the potential risks in your surroundings, you won't be willing to do anything about it, and consequently, that'll get you hurt. The final A is action. Now that you know about the potential dangers and have the attitude to remedy the situation, take corrective action required, whether that means putting on PPE or informing your teacher about certain operational hazards present in the shop. Now that you've made sure your environment is safe, let's get to actually making our part. The first thing you'll want to do is gather stock material. The stock must be at least 6 inches in length and 2 inches in width, and close to 1/8 of an inch in thickness. Now that you have your material, you'll want to make sure that the material is square. If not, you might need to file down the material to get it to become exactly square. Next, apply your engineer's glue onto one of the surfaces of the material. Now, using the drawing I showed you initially, use the scriber, the engineer's square, and a ruler to mark out all the straight lines at the appropriate locations and lengths. Now, duplicate everything you did with an offset of about 5 mm. This is the line the bandsaw cuts will follow. Then, use the spring divider to draw 2 circles, one for the 6mm through hole and one for the 8mm countersunk hole. At the center of both these holes, use the center punch and strike it with a hammer to make a small indent. Here we can see how it might potentially look with the scribed lines on it. Note that the dashed lines are not actually scribed in. Next, you'll want to make several relief cuts around the curved sections like the diagram shows. This is because without them, you might damage or break your bandsaw blade. Next, once those relief cuts are made, you'll want to use the bandsaw to make a cut following the offset lines you scribed on. Moving on, since the bandsaw should only have left a very rough cut, which is bigger than the part needs to be, use the file to file down all edges until everything meets the initially scribed lines you made. Next, where you mark the hole to be, use your 6mm drill bit to drill away all the way through the material. Now, swap out your 6mm drill bit for an 8mm drill bit and only drill slightly into the material on each side such that a countersink is visible. Next, use the letter stamps and a hammer to place your letters of your name side by side to form your entire name. Finally, use a caliper to recheck all measurements initially created, and if they are too large, use a file to get them to their exact dimensions. Finally, use your emery cloth to polish any rough edges and give your product an overall nice look. And that's it. Now go ahead and use your product. Before we go, I actually wanted to show you an alternative way of doing things that involves only using a milling machine. Since I already extensively went through the initial method, I will only quickly skim through this and use CAD simulations to help support what I'm saying. This alternative method involves using a milling machine initially with an end mill to trim the thickness of the stock to the appropriate thickness. This first step can actually be used with the normal process initially if your stock is too large. I'm going to let this end mill make a couple more passes and then we can look at the next steps after that. Now that we're the correct thickness, we can begin to make the cutout of the rough shape. You'll want to switch to a much smaller end mill so you can more precisely match the boundary of outlines you made initially. You are likely going to be able to get this outline closer and cleaner than you would be able to with the bandsaw, though it will take more time. Once that's done, we can now drill the holes in the exact same fashion as we did before. So to recap, here's what we did very quickly. Thank you for listening to my video presentation today. Hopefully I showed you 2 interesting ways on how you can make the T-slot cleaner, and hopefully you learned something along the way. And remember to keep those T-slots free of chips.